Hello everyone, welcome back to another video. Today we're going to be looking at trigonometry. Let's take a look at these questions. Question 5.1 reads, simplify the expression to a single trigonometric term. We've been given tan negative x times cos x times sine of x minus 180 minus 1. Now, when I do these problems, I always go back and refer to my cast diagram. So the cast diagram, just remind ourselves here, you have CAST. This is telling us what trig ratio is positive in which quadrant. Now, this is 0 degrees. That's 90, 180, 270, and then this is slash 360. Now, this second quadrant, this is the 180 minus theta quadrant. The third quadrant is the 180 plus theta quadrant. This fourth quadrant is the 360 minus theta quadrant. The next thing we need to remember is that angles are normally measured anti-clockwise. And so if we are measuring angles clockwise, that means the angles are going to be negative angles. Okay. So keeping that in mind, let's go and attempt these problems. So tan of negative x. So tan of negative x means that we are at 0 and we are rotating it to an acute angle. We are rotating it clockwise, which means that we are sitting somewhere here. That would be negative x. Right? So it would have been a rotation like that. Now that is the fourth quadrant. Only cos is positive in that quadrant, and so tan will be negative. So 5.1, tan of negative x will be minus tan x. Okay, then cos x will remain since there's nothing to do there. Next one is sine of x minus 180. Now let's look at how I do this one. So sine of x, which means it's sine of positive x, which means there was a rotation anti-clockwise through an angle of x. And then the minus 180 means that they've rotated it now 180 degrees clockwise, which means we are ending up in this quadrant here. This is the third quadrant and only tan is positive in that quadrant. So sine of x minus 180 will then reduce to minus sine of x. And then we have the minus 1 on the side. Now let's expand tan x. Now tan x can be written as sine x over cos x. And this negative and that negative, since it's multiplication, they will cancel or they will make a positive. So let's leave that out. Then we have multiplied by cos x, then multiplied by sine x, and then minus 1. We can now cancel, so that cos can cancel with that. That's going to leave us now with sine x times sine x, which is sine squared x minus 1. Now, remember they said they want the answer to a single trigonometric ratio or single trigonometric term. Now, we know an identity, and the identity is sine squared x plus cos squared x equals 1. Now, since we want sine squared x minus 1, what we can do is we can take this across and take the 1 over, leaving us with sine squared x minus 1 equals minus cos squared x. So our final answer in this case is going to be minus cos squared x. Okay. Let's move on. Question 5.2. Question 5.2 reads, given cos 35 equals m. Now, when you get a question like this, generally what I would like to do, I like to draw a diagram. So my diagram will look like this. 35 degrees. M means that the adjacent is m. The hypotenuse must be 1. Therefore, this side must be 1 minus m squared. Next, without using a calculator, determine the value of each of the following in terms of m. Cos of 215. Now, we obviously will need to break this up a bit. So 215 I can rewrite as cos of 180 plus 35, right? Now 180 plus 35, you can think of it as 180 plus theta. Now 180 plus theta is the third quadrant, and only tan is positive in that quadrant. So this will reduce to minus cos theta, or in other words, minus cos of 35. We know cos of 35 is m, so then the answer here is going to be minus m. So 5.2.1 minus m is our answer. All right, let's move on. Cos of 20. Now we know that in a triangle, cos of 20 will equal to, sine of 20 will equal to cos of 90 minus. So what we can do is we can write this as cos of 90 minus 20. Now 90 minus 20 is 70, so we can say that's cos of 70 degrees. And 70, since there's no 70 on our diagram, we can break it up. We can say that cos of 70 is the same as saying cos of 2 times 35. Now that is one of our double angles. Now remember the double angle cos of 2a. We can expand that. That's going to be 2 cos squared a minus 1. Now let's substitute that back. Sorry. So 5.2.2, we said that it's going to be cos of 70 degrees. And then cos of 70 is the same as saying cos of 2 times 35. And now what we're going to do is we're going to use that double identity, or that double angle. We're going to have it as 2 cos squared 35 minus 1. Now we know what cos 35 is. Cos 35 is m. So it's going to be 2 times m squared minus 1. And let's expand that. So 2m squared minus 1. And that's our answer. Okay, question 5.3. Determine the general solution of this long, crazy expression or equation. So what we can do here, okay, let's look at this. So I'm seeing here 4x and I'm seeing here 4x. I'm seeing x and x. So I'm thinking maybe cos of a plus b, maybe cos of a minus b. We're not sure yet. We may need to rewrite it a bit. So let's rewrite it. So we can rewrite this as cos 4x times cos x, then plus sine 4x times sine x. Now we should recognize this. Okay, this is the expansion of the identity cos a minus b. Right? So from here we can simplify this, and from here we can go to cos of a minus b. In this case, it's going to be 4x minus x is equal to minus 0.7. And the whole point of doing that was we needed one trig identity in order to solve. Okay? And now what we'll do now, since we want general solution, we're going to say 3x is equal to shift cos 0.7. And this is going to give us our reference angle. Remember, we take the positive value. Okay? That means our reference angle in this case is going to be, so 3x is equal to 45.57 degrees. Now, remember, in this case, cos was negative. And cos is negative in 2 quadrants, in the 180 plus quadrant and in the 180 minus quadrant. So we need to apply both of them. So we'll say 180, so we'll say 3x is equal to 180 plus 45.57 plus k360. And then we'll simplify, we will get 3x. Let's just simplify for x now one time. So x is going to equal, divide everything by x, and you're going to get 75.19 plus k times 120. Now in the second quadrant, we're going to get 3x is equal to 180 minus 45.57 plus k360. We'll simplify and divide everything by 3. We're going to get x is equal to 44.81 plus k 120, and not forgetting for each one, k is the element of z, k is the element of z. All right. Now that should leave enough space for the last question. Last question says prove the identity. So sine 4x times cos 2x minus 2 cos 4x times sine x times cos x over tan 2x. Now, you can start with either side. You prove the left side equals the right side equals the left side, but you cannot work with both of them at the same time. Okay? Now, since I'm going to say that no, the right hand side is as simple as I can possibly see it, I don't want to interfere more with it. So I'm going to obviously work with the more complex side, which is the left hand side. All right? So the left hand side, we should have enough space now. Here, all right. Let's start here. So my left hand side, let's just rewrite this. So we got sine 4x multiplied by cos 2x. And now what I'm going to do is I'm just going to rewrite this a little bit. Because, and you'll see why in a minute, these two terms, the sine x, cos x, I'm going to bring it to the front. Watch what happens. So minus 2 sine x, cos x, and then multiplied by cos 4x, and then divided by tan 2x, I can write as sine 2x over cos 2x. Now, the reason why I've brought this to the front is now you can see that 2 sine x cos x is an identity that we know, right? And that is sine 2a. Okay? So, let's rewrite this. So we're going to get, one second, here we're going to get sine 4x times cos 2x minus, this is going to be sine 2x times cos 4x, and divided by, again, sine 2x over cos 2x. Now, just like we did in the previous one, we can do some rearranging here. We can do this rearranging just so that it makes the identity a little bit more clearer for us. So I'm seeing 4x here, so I want to have a 4x there and then 2x here. So let me rearrange it. So I'll put the cos 4x first and then the sine 2x. Remember, multiplication, it doesn't matter. You can rearrange it. So here is going to be cos 4x and then times sine 2x. Now, if you look at the way that this is written, you have sine 4x cos 2x minus cos 4x sine 2x. That's an identity. That's the identity of sine a minus b. So this can be rewritten now as sine of 4x minus 2x. And then that's going to be divided by sine 2x over cos 2x. Now I'm going to simplify a bit. This is going to be sine 2x times cos 2x divided by sine 2x. Right? Now the sine 2x will cancel, leaving me with cos 2x. And now cos 2x, that's a double angle, and we can expand that as cos squared x minus sine squared x, which is equal to my right hand side. Okay, that was it. So the key here was just to do some rearranging. The rearranging will help you to see these identities a bit more easier. Right, next question. It reads, in the diagram below, the graphs of f of x and g of x are drawn for the interval a and b are 2 points of intersection of f and g. Okay, without using a calculator, determine the values of x for which cos 2x is equal to minus sine x for the interval that's given to us. Okay, so without using a calculator means we're going to have to use reduction or double angles or something related to that. So cos 2x, now cos 2x is a double angle, and I'm seeing that since I have sine x on that side, right? And I know that I'm seeing here that there's one solution, there's two solutions, there's three solutions. So the way that I'm thinking here is that I want more than one solution. So the way I can get more than one solution is if I get a trinomial or quadratic formula. And now I'm looking at that cos 2x and I'm thinking, how can I get a quadratic, keeping in mind that I have that sine there? Now I know that cos 2x opens up to a double angle that has sine in it. And I can use that, and it's going to give me a quadratic. So cos 2x, instead of cos 2x, I'm going to rewrite it as 1 minus 2 sine squared x. And that's going to equal minus sine x. Okay, this is question 6.1. Now I have a quadratic. Now let's write it in that standard form. So I'm going to have here 0 is equal to 2 sine squared x minus sine x minus 1. Now if it's not too clear for you, we can rewrite this as 2x squared minus x minus 1. Now you can use your calculator, of course, but basically you're going to get the following factors. You're going to get 2 sine x plus 1. And then you're also going to get sine x minus 1. Now from here, you may be asking, how are we going to get more than two solutions? And you're going to see now. So you're going to get you're going to have 2 sine x plus 1 equals 0. That means that sine x is equal to minus a half. Now from here, we can get multiple solutions, right? Now, since it's negative, we're going to go the general solution route, okay? We're going to work out our reference angle. So we'll say the reference angle is equal to sine shift or shift sine half. And that's going to give me 30 degrees. Now we know that sine is negative in two quadrants. It's negative in the third quadrant and it's negative in the third quadrant and fourth quadrant. So let's do the third quadrant. Third quadrant is 180 plus 30 plus k 360. Right? That means we're going to get 210 plus k 360. That's going to be one value. Okay? The next one, well, the fourth quadrant is going to be 360 minus. So 360 minus 30 plus k 360. That means x is equal to 330 plus k 360. But now we need to be careful, right? Because remember, the only options we have here, right? The only options we have are between minus 180 and 180. Minus 180 and 180. Now, if we substitute k as minus 1, right? If you substitute k as minus 1, so when k is equal to minus 1, then the one solution we're going to get is x is equal to 330 plus minus 1 times 360. So that's going to give me minus 30 degrees. So that's going to be one solution, because that is a valid solution. It's between minus 180 and 180. So then this is most likely here going to be minus 30 degrees. Okay? Now we're looking for another solution. All right? And to get the other solution, what we can do is we can substitute another value. Right? Now, to get the other value, let's substitute k as minus 1. Minus 2. So when k is minus 2, we're going to get... Oh, actually, we don't need to. We can substitute it into the other equation. So k is minus 1, we can substitute it in there. So we're going to get x equals 210 plus minus 1 times 360. And that's going to give me an answer of minus 150 degrees. And that's my other solution. And that will go right here. So we've got two solutions. We just need the third solution, which is going to be somewhere here. It's going to be some positive angle. Now, remember, we only just worked with this one bracket. We still have to work with this other bracket. And the other bracket is going to be sine x is going to equal 1. And when is sine x equal 1? When x is equal to, well, shift sine 1, and that's going to be 90 degrees. And then plus k 360, but in this case, we don't need the k 360 because we know it's going to be 90. So that's 90 degrees. So we have our three solutions. Okay, not too bad. Okay. Question 6.2, use the graphs above to answer the following questions. How many degrees apart are points A and B from each other? That's not too difficult. We can see A and B are 120 degrees away from each other. Okay. Next one. For what values of x, of which values of x in a given interval will f prime x? Oh, okay, so here they're talking about gradients. Will the gradients be, well, the product of the gradients be greater than 0? So when will I get product of the gradients being greater than 0? When the gradients themselves are positive. So when both of them are positive. So positive times a positive is a positive. Or when both of them are negative. All right. Now let's look at our graph. And let's divide this up into regions here. So I have this region where that intersection. I have this one here, that intersection. I also have my center line, my origin. I also have this here. Now we are looking for where the tangent lines are going to be positive or where both the tangent lines are going to be negative. So I'm going to draw the tangent lines in with red. I'm looking here between 0 and 90 degrees. If I draw a tangent like this, that's going to give me a negative slope. And likewise here, that's also going to give me a negative slope. So here you can see that the tangents are negative between 0 and 90. So both are negative here. So the product of two negatives will give me positive. So it's going to be one value will be between 0 and 90. And then if I look at between 90 and 180, I can see, let's use blue here, I can see that these are positive slopes. Like this. So here both are positive. So I'm going to have two answers here, but both of them will give me positive output. So the answer here is going to be x must be between, so 6.2.2, x must be between 0 and 90, or I can say that x must be between 90 and 180. All right. Next one, and the last one for this graph question. Determine the values of k for which cos 2x plus 3 is equal to k will have no solution. Now, we don't have the graph of cos 2x plus 3. But if I take the 3 over, then I can get the equation that we're currently working with. So 6.2.3, what I'll do is I'm going to say cos 2x is equal to k minus 3. Okay. Now, we know for a cos graph, right? Obviously, a cos x graph or cos 2x graph, the graph starts at 1 and it ends at minus 1. So the range for that graph, the range for a cos graph, so just quickly sketch this out like this. For a cos graph, obviously the amplitude hasn't been changed, so the amplitude is 1. It starts at minus 1. It starts at 1 and it's between 1 and minus 1. So it's going to have no solution when this k value falls below minus 1 or when this value falls above 1. So we're going to have two solutions here. We're going to say when k minus 3 is going to be, well, let's write it out a bit neater. So when k minus 3 is less than minus 1, that's when we're going to have the first no solution. We can solve here. We can say k is going to be less than minus 1 plus 3. That means k is going to be less than 2. that's the first one, right? And the second one is going to be when k minus 3 is going to be greater than 1. That means k is going to be greater than 4. Those are my solutions. Okay, let's move on. And this is the last question. This is the trig in 3D question, right? And this question reads, point B, C, and E lie in the same horizontal plane. ABCD is a rectangle. CDE is a triangle. Each piece of the board is placed perpendicular to the horizontal, and they've given us the angles, and they've been kind enough, they give us a diagram. And 7.1, they give us obviously the 6-mark question straight away. Show that DC is equal to BC divided by 4 cos squared x. Okay, now if I look at this, I see that, okay, DC falls in this triangle right here. So it would make sense to start with that. And let's redraw this triangle out so it's a bit easier for us to see. That's x, that's 90, that's DC, and then that's E. Okay, now we have some options here, but we need to be smart about this. Because this line CE is common to this triangle and this triangle, we need to solve in terms of that line as well. There's no point in using DE, because DE is not common to any other line. Okay, so we need to use this triangle and obviously this triangle. So we need to also find the common line between them, which is CE. Right? So we're going to use CE, sorry, that's C. Let's neaten this up a bit. That's C. So obviously we need D, and then we need to use CE and that angle X. So we got the opposite, we got the adjacent, we got the angle, so we'll use tan here. We'll say that tan X is equal to DC over CE. Now let's rearrange this in terms of CE, since CE is the common theme here. CE is going to equal to DC divided by tan X. Okay. Now let's shift our focus to this triangle right here. Okay. Now let's solve. Since obviously we can see that there's a BC there, and we just worked in terms of CE, we need to use BC and CE in our new equation. So BC, CE, we got an angle, so we're going to use sine rule here, right? And we're going to say that BC divided by sine of 2x is equal to CE divided by sine of 30 degrees. Okay? Now, let's take this across. So we're going to have BC divided by, BC times sine 30 divided by sine 2x. Let's expand that while we have it. That's going to be 2 sine x cos x. And that's equal to CE. Now we know what CE is. CE is DC over tan x. Okay. Now let's simplify and then do our reductions and see how we can work our way to that, to the expression that they want. Well, we know sine 30 is half. So BC divided by 2 and then times 2 sine x cos x. So remember, sine 30 is half. I just brought the denominator, I brought the 2 down to the denominator. And that's equal to DC divided by tan x is sine x over cos x. Right? Next, what we can do is let's tip and times this. So neaten it up a bit here. DC divided by sine x over cos x is the same as saying DC times cos x over sine x. Okay, so let's replace that. So DC times cos x divided by sine x. Okay, now remember we want DC, so we need to take everything across. So this will go up to the numerator, this will go down to the denominator. So we're going to get BC times sine x divided by, now 2 times 2 is 4, then sine x times cos x is cos squared x. That's equal to dc. Now the sine x can cancel, leaving us with bc over 4 cos squared x equaling dc. And that's it. Okay, the last question now. If x is equal to 30 degrees, show that the area is equal to that. So the area of this shape, okay. So the area of this rectangle, we can work out the area of the rectangle. That's going to be length times breadth. Okay, so we can say AB times BC. Okay, so area is equal to AB times BC. Okay, now they tell us that x is equal to 30 degrees. Now what we can do is, we can actually work out what DC is in terms of BC. Yeah, let's do that. So we can substitute here. So using this, because we just did this. So we can say that BC divided by 4 cos squared 30 is equal to DC. Right? And then from here, what we can do is we can get BC divided by 4, and cos of 30 is square root 3 over 2. So square root 3 over 2 all squared equals DC. Let's simplify this a bit. That's going to be BC over 4 into 3 over 4. So that's going to cancel with that. And that's going to equal DC. So BC, and DC. So BC divided by 3 is equal to DC. In other words, BC is equal to 3DC. So basically, the length of DC, the length of line DC, if you multiplied it by 3, you're going to get the line BC. Okay, and we know that AB, since it's a rectangle, AB and DC are equal. So let's replace this. So AB, instead of AB, we'll write DC times BC. Okay, now we know, do we need to use that? No, we want AB. Let's just keep AB. Right? So we say DC is equal to AB. Right? If DC is equal to AB, that means 3DC is going to be 3AB. That means BC is going to equal 3AB. Yeah, there we go. And I think we get it. So I think we're going to get it now. So what I've done here is I've said that DC is equal to AB. That means 3DC will equal 3AB. And then from there, we can say that BC is going to equal 3AB. Now we just need to substitute. So instead of BC, here, I'm going to put 3AB. And then here I have AB. And you can multiply, you're going to get 3AB squared. And that's it. Solved. Thank you so much for watching. If you found this useful, please leave a like, share, subscribe, hit that bell icon. And if there's something specific you want me to do, or some question, or something you want me to clarify, you can let me know in the comment section below. And until the next one, thank you so much. Bye.